Now, the good news about this section is that it's all formulas and that you don't have to think too much. Okay, for some of y'all that don't like thinking, you might like this, okay? 6.1 and 6.2. I'm going to skip a lot of this because I want to get to the formulas that make, okay? Now, when you're talking about discrete and continuous, remember, discrete is concrete, continuous is not concrete, or is continuous, which means it's measured. So we're going to be getting into probability distributions in this section. Probability distribution, let me see if I can find one. Well, that's a discrete. Discrete means what? You count. What is continuous? Continuous means is measured. Okay? So that means that continuous is going to have decimals and what? Fractions. So go ahead and write this down. Just draw a number line and put discrete. Discrete means integers. What is integers? What is a 25-cent word for integers? Numbers. Whole numbers. What? What? I didn't hear you. Okay. So discrete equals whole numbers. And this is just kind of a refresher of what you already know. And continuous is whole numbers, fractions, and what? Decimals. And fractions and decimals, that's usually what's measured. Half a cup of whatever, half a gallon, half a mile. Everybody with me? You know, usually when you get into your real world measurements, you're not going to come up with exactly, if you measured from here to west side, okay, you would come up, if you measured with a roller wheel, you would come up with a different distance than if you measured with your car odometer, okay? If you got on the map and did a straight line from here to west side, it would be totally different from what you did, you know, going down the road. So anytime you measure something, whether it's a distance, it's going to be decimals and whole numbers. So that's just a little review of what we talked about in Unit 1. Okay? And I'm not going to go into this. Probability distribution. What is a probability distribution? A probability distribution is when you have events on the left and you have the probability of those events on the right. Let me give you an example. Let me go to my handy dandy. I forgot to pull up the whiteboard. And pull up the whiteboard, and I'll just do it on the, I'll do it on the slide, because the slide's probably going to show it also. There we go. And present. There we go. So if I have the probability of, well, let's just make it simple. I'll just write down, okay, it's not, there we go. There we go. Probability of having a boy with 2 children and let's say that you're at a facility, you know, fertility hospital or whatever, and with their treatment, the probability of a boy is equal to 0.47. Okay, with their history. All right. Now, what is the probability when you're born? What is the probability of you being a boy or a girl? 50%. I don't care what anybody says nowadays or 20 years from now. When you're born, you have the equipment of a boy or you have the equipment of a girl. All right. Now, with that being said, what is the probability of a two-child outcome? Two-child outcome is boy, 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 girl, girl, boy, and girl, girl. Girl. Everybody with me? Does anybody have a problem with that? Because that's the only outcomes that you have with two children. Remember me a long time ago telling you to make sure you could do 2 children, 3 children, and maybe even 4 children. And I told you to look it up on Google because it's too aggravating to do by hand. Do you remember me telling y'all that? You know, I don't want to tell me nothing. But anyway, all right. So this is 1 boy, right? I meant 2 boys. So that means this right here would be 0 boys, right? This right here would be 1 boy. And this right here would be 2 boys. Everybody with me? So now I can put this in a probability distribution. Probability distribution is a 25-cent word per table. The probability of the event is over here, and the event is over here. 0 boys, 1 boy, and 2 boys. Now, of course, you're not going to have the boy in there. It's going to be 0, 1, and 2. The probability of 0 event happening, the probability of 1 event happening, the probability of 2 events happening. Everybody with me? Could this be the World Series 5, 6, 7 games? Yes. So anytime you see the World Series number of games after 5 games, what is the probability of the World Series going to 6 games or 7 games? That's how they set this up. Now, the probability of a boy is at this facility, whatever, is 0.47. So therefore, I'm going to use that 0.47 to give me the probability of these events. Okay, now, you could use the traditional method and say, well, how many out of 4 is going to be 0 boys? 1. 1 out of 4 is point what? 2.5. That's your traditional. Everybody with me? That's your traditional way. 2, that's 0.5. And then 3, the last one, 2 boys would be what? 0.25. All right, that's your traditional way. Now, if you're given this probability here, I'm going to write this in blue because I don't know what the traditional way is today, but when I was growing up, the probability of a boy or boys equals blue, so 0.47. And then, therefore, somebody give me the complement of that, and that would be the probability of what? A girl, and that would be what? 0.5 what? Thank you. Okay, now the probability, one of those probabilities is going to be given. Okay? Everybody with me? So, how would you take that and use that in the probability of an event happening? You want to put that up? Instead of insulting my intelligence? Now let me get my train of thought back. What's that look for? Well, you insult my intelligence when you put your phone down under the desk thinking I'm not going to be able to tell that you're texting. That's insulting my intelligence. All right. Now, how did I do 0 boys? Well, tell me what 0 boys mean. 2 girls. So that would be 0.53. And I'll do this in red. 0.53 raised to the what? Second power, because that's the probability of a girl and a girl. So you're going to use the complement to find the probability of 0 boys. You see how you're using the complement? All right, so what would one boy be? Well, that's going to be hold on. That's going to be 0.43, 47, sorry. And then 0.47. And then red, 0.53. 0.53, and then you're going to add those two. Why? Because what is one boy? Boy, girl, or what? Girl, boy. Boy, girl, or what? Girl, boy. And what would two boys be? Be 0.47 or 0.47 raised to the what? All right, somebody crank that out for me. And just make it to 4 digits. Let's do 4 digits to keep it even.
0.47
I'm sorry. What?
0.47 second power is 0.2209.
0.2209. That's for
The bottom.
Why do you start from the bottom?
Because you asked.
Because I'm going to start from the top.
No, because that's what I wanted to do.
I tell you what.
Before you said it.
That's why you're going to fail. That's why. Okay, so 0.22 what?
09.
From the bottom. We're starting from the bottom, people. All right. Somebody give me 1 and 0. Somebody give me the middle. Let's narrow this down so we don't get it confused. Let's go with 1. Somebody crank this out. What do you get? 0.4986. 2. And somebody do the top one.
0.2809.
0.280 what?
9.
Okay. I hope everybody's writing this down. Is everybody writing it down?
Yes, sir.
So let's see. A couple of people not writing anything. An event and the probability of an event. Now, there's 2 things that you have to look for here. In a probability, this right here is a probability distribution. So you need to write that down and you need to highlight it. That is a probability distribution. Now there's 2 things that you need to check to see if you have a probability distribution. One thing that you need to check is to make sure that all the probabilities are between 0 and 1. All your probabilities are between 0 and 1. 1. That means no negatives. That means no numbers above 1. So all of these, 0.28, that's between 0 and 1. 0.5, that's between 0 and 1. And 0.22 is between 0 and 1. And the other one is that the summation of all your probabilities are equal to what? 1. Now, if you was to do a probability based on traditional methods, what would the probability of 0 girls be? We already talked about that. 0.25. What's the probability of 1 boy? 0.5. And the probability of 2 boys is 0.25. Now, the other variable that's thrown into this is the probability given in the problem based on past statistics. Will you see this one again? Yes. Anything, the boy, boy, girl, girl, you're going to see that. So this is a good problem to write down as an example in your notes. So you won't, and it's also a good problem on any standardized test. And the main thing you need to remember is what is a probability distribution? Is a table with the events, the event number on the left, and the probability of that event happening on the right. How many of you have seen or worked with in your previous 120 class, or whatever class you call it, probability distributions? One or two of you? Now again, is anybody going to walk up to you at your job and ask you this? No. But you may have to either present this material, or you may have to what? Watch this material in a meeting. Especially if you're in a field that does a lot of quality assurance. All right, I'm going to erase this board because we got to see what it's going to. You're supposed to erase the whole board. Why aren't you erasing the whole board? Oh my gosh. I don't know why it's not erasing the whole board. It's supposed to. Oh well. Discard. There we go. Here's another one. Write this one down. This is a probability distribution that's already calculated for you. It's calculated because sometimes they don't want you to calculate it. They just want you to look at it, determine if it's a probability distribution. That means you need to add up all your probabilities. You see that there's not a negative. You see that all of them are between 0 and 1. So the only test left is to add them what? All up. 6 cent, 58 cent, 64 cent, 86 cent, 96 cent. 96 cent plus 4 cent is what? $1. So it does equal a probability distribution. So this could be the probability of, 0 boys, 1 boy, 2 boys, 3 boys, 4 boys, or 5 boys having 5 kids. Why anybody in the world would want to have 5 kids? I could not take the 2 I got. And one of them's in DSS all the time. So, that's a joke. Haha, it's not fun. I'm not being serious. Speaking of bad decisions, I know several of my high school, classmates when I was in high school, they decided to get married right out of high school and have like 15 kids. That didn't turn out too well for some of them. Another bad decision. Bernie. Next, and like I said, you add those up, and they should equal 1. And there's your 2 tests. I already showed you that. But you can write them down again if you want to. What if you have a negative? Then you mark the problem and say, cannot what? Cannot do it. It does not exist. If there's a 2 or a 5, cannot do it. You just mark through it and go to the next problem. Now, there will be something there that says, can you do this problem? And you say no. Because you have a negative, or you have a number above 1, or you add them all up and you get 1.6. If you add them all up and get 1.6, you can't do the problem. So you're done. I do not give those on a test, but you might see those on a standardized test. Always make sure you check the probabilities to see if they're between 0 and 1 and add them all up, because on a standardized test, there may be one that you can't do. And this is 1. Now, I'm not going to ask you to write each one of these down, but I just want you to you know, the summation of all these is not $1, but what? 97 cents. Now, I know some of y'all might want to be in this world, but 97 cents does not equal what? $1. But that one is not doable. This one's not doable because you have a what? A negative. So that one's not doable. This one is doable because both tests are met. And of course, they want to throw a histogram in here. I'm not going to insult your intelligence by saying, okay, this is a histogram, and this is how we do a histogram. I'm not going to do that. I've shown you how to use your Excel spreadsheet. I've showed you how to use your calculator. Type those in, hit histogram in your calculator, and that's maybe a standardized test question. I usually don't ask you to do that. I ask you to do what we're going to do in just a minute. There we go. The mean. Find the mean. How do you find the mean of a probability distribution? The summation of the event times the what? Thank you for articulating that with volume instead of. So we're going to have to make another column beside our probability in our Excel spreadsheet. And what's that column going to be called? X times what? P of X. Now we're going to go ahead and do the standard deviation formula. Hopefully this slide will have it next. And then you'll have the two formulas for 6.1. Now, it shouldn't take you that long to write down that formula, so I'm just going to go ahead and move on. Okay, they're going to go ahead and do an example. I'm not going to do that because I don't like the way they do it, so we're going to move on. And X bar, we know that X bar is a summation. Okay, I'm not going to go through that. Y'all know how to find X bar. You add up everything and divide by N. I'm not going to go through that for you. So you'd have to add these up, but I'm not going to do that. Okay, there. Add them all up. Now, if you want to, go back and look at that, there you go. So that's going to be all those divided by 100, and I'm not going to. And that's 1.49. And there's your data plots. I'm not going to go over that. Y'all know how to plot. Expected value. Okay, now this problem, write down. We're going to go back to the mean in just a minute. Write this problem down word for word because this is a standardized test question. I don't care if you're taking the ACT or the SAT, this is going to be on there. So you might want to write it down. And it's always a life insurance question. I'm going to give you a second or two to write it down. And it basically, you dead or you're not dead. I'm sorry. Survive or do not survive. I don't want to offend anybody by saying dead. Now, sometimes the question is based on the person. Sometimes it's based on the insurance company. It will say that in the problem. At the end, it will say, compute the expected value of the policy to the what? Insurance company. So you need to highlight insurance company because we're looking at this as for the insurance company. Now, once you set this problem up as a table, it makes a whole lot more sense than reading it in the paragraph. You have two columns. You have two events. Dead or not what? Dead. If you die, then you pay $530 to the what? To the insurance company, but you get back what? A whole bunch of money. minus your $530. What if you survive the year? If you don't have a wreck or anything and don't die, then you're out how much? $530. That's the reasoning you have to think about. Now, who's benefiting? Well, if you're the insurance company, who benefits? The insurance company benefits when you stay what? Alive. They lose money when you what? Die. So from the insurance company, you're going to be looking at the survival. But in order to find the mean, which is what they're asking for here, and you might want to write down beside this problem, mean, we're going to add them all up. So, what is the probability of living? Well, it says in the problem that the female will survive by 0.99791. Why is that so high? Because females are the smarter of the two genders. What do you mean, Hubert? Why do you say that? Go to YouTube and pull up dumbass videos. And how many videos do you see women jumping off of the top of a building or a house, imitating WWE? How many females do you see standing in front of a rolling round bale of hay coming down a hill? Y'all get my point? Okay, there's not a lot of females. Most thing you see females doing is dancing on the table and the table falling or something. Or are they falling off the table? That's all you see with females. Men, however, are stupid. And we all contribute it to what? Starts with a T. Testosterone. Exactly. So if you do stupid stuff, women, that means you got a little bit higher level testosterone. So if this was a male, the survival rate for a male, put a male in a car when they're 16, 17 years old, and they think they're what? Superman. That probability is going to go down for a male. Do you think insurance companies think about dumbass Dist syndrome? Yes. Did I say dumbass Dist syndrome? Dumbass syndrome. Yes. Insurance companies think a whole lot about the years 18 through, technically it should be 30, but I think it's 25. Okay? 18 through 25 as the dumbass years. And that means that the probability of a male surviving the year is higher or lower than a female? Lower. Because of jumping off the top of a house into a table. You haven't seen some of those videos?
I have.
And how many of them are women?
None of them.
None. There's 2 or 3 things that I can say when I go to heaven, and I'm pretty much sure I'm going to go to heaven. If I don't go to heaven, then, I think I haven't done too many bad things, real bad things in my life. Okay? But there's 2 or 3 things I can say, and one of them is I didn't jump off a building or stand in front of a rolling bale of hay. Y'all seen that video? Where the guy is trying to jump over the round bale of hay rolling down a hill. You'll pull it up? Yeah. Of course, he gets the crap knocked out of him because the bale, I figured the force came out to be like 9,000 foot-pounds. I figured it out using physics because I know how much a round bale of hay weighs, anywhere from 12 to 1,500 pounds. And it's rolling down a hill, and I measured how fast it was going by using the scale of the guy. I figured him about 6 foot. And then I measured how fast it was going, and I timed it. So I figured how fast the bale was going in the video. I did a whole lot of work on this. and it came out to be 9,000 to 10,000 foot-pounds of force hitting 120. It looked like the guy was puny. I don't know. Anyway, it knocked him how far back?
Really hard. At least like 10, 15.
I bet it broke. I bet it broke at least 5
What would have
ribs.
been terrible was if you got hit and then got ran back over by you. That's what I thought was going to happen. Yeah, he just-
So again, we go back to decisions. You are your what? Decisions. Now a lot of people say, what the hell does that have to do with math? You are your decisions. Here, the insurance company knows what 18 to 25-year-old kids, boys do, so they know that the female is going to be a whole lot higher than the male. And if you don't think insurance companies think about stuff like this, they do. Because what do they not want to give up? Money. They're just like the bank. 2 things in Vegas. Those 3 things, all they care about is what? Money. So, take 530, multiply that by 0.99. Take negative 249, 470, multiply that by 0.002. Because what is the complement of living? Dead. So what is the complement of 0.99791? 0.00209. So multiply that out, add it, and you get $7.50.
So that probably
No, that's the expected value. The expected value of that. So that you could say that they are expecting $7.90. Now, what do insurance? Anybody in here, parents into insurance? Maybe. Okay. What do they want? Do they just want one person? No. What do they want? They want all the people they can get, because all the people they can get means that $7 turns into $14, turns into $21, turns into, the more people they get, the more money is what? Coming in. Now, that's not meaning I pay for my daughter and me they're talking about car insurance. Okay? And I'm with Farm Bureau. You know how much and I've never, knock on wood, I've never had anything bad happen to me. My daughter had her car stolen into by a couple of meth heads, but that's it. No bad wrecks or anything. Anybody want to guess what my insurance is a year on me and my daughter?
200
$2,000 a year,
a year.
which is $1,000 every 6 months. And I guarantee you, some of you that are driving, your parents are paying about the same. Why? Because even though you're female on this side, because I got some males over here, females are going to have, I don't know if this is true or not, female may have a higher rate or lower rate. I don't know which one it is. But again, the insurance companies take all that information into effect. So make sure you know how to do that problem. It's real simple. Once you what? When you put it in table form, it makes sense. We'll get to that mean and standard deviation. And there we go. There is your, and I'm going to use the second one. Okay, I'm going to mark through the first one. I don't want you to use that one. Okay, so mark through that one. I'm going to use this one. The standard deviation is equal to the square root of the summation of x squared times p of x minus the mean squared. Now all you got to do is read the formula. Don't write the formula down and then say, how do we do it? Read the formula. X squared times p of x, meaning you got to have another column called x squared, and then minus the mean squared. Now, I'm going to go to my handy dandy, and we'll write that down again. Oh, you should have that down. You don't have to write all the words. Okay? I'm going to go to my handy dandy spreadsheet. And we're going to do a problem that I would give you on a test, or you might see on a standardized test. So you want to put this in your notebook. So let's go with x let's go 0, 1, 2, 3, 4, 5. So there's our events. Our probability of the event. If I could type. And we'll go with 0.1. What?
0.273.
No, I'm just going to make these up. 0.2, 0.3, 0.2, 0.3. What is that? Let's see, that's 3. That's okay. I got to shave off 1 here and 1 here. So that's 6, 7, 8, 9, and 0.1 there. Of course, the first thing we do when we're given one is, I appreciate you offering that information, but I'm just going to make it up. It's easier. So we can do this because what? They're all equal to 1, and they're all between 0 and what? 1. And OCD kick in. There we go. I might as well do this too, because I am a little bit OCD. There we go. All right. So first of all, we got to find the mean. So what is the mean? Well, the mean is the summation of x times what? So I've got to go over here and I've got to make x times p of x. So go ahead and do that in your notes with your calculator. I'll do the first one for you, 0. I'll even do the second one for you, 0.1. There you go. And you should be able to multiply 2 times 30 cents in your head. Duh.
Isn't it x squared?
The mean is p times, you're thinking of the standard deviation. We haven't done that yet. Can I be in charge for a while? Okay, thank you.
No problem.
Oh, this female estrogen, I'll tell you, I just can't take it. It's all about control, manipulation, and power.
I'm just not paying attention.
I know. 2 times 0.3. What's 2 times 30 cents? Okay, this one's real hard. What's 3 times a dime? I hope you're not using a calculator. What's 4 times 30 cents? $1.20. Okay, what's 5 dimes? 50 cents. Now I'm going to add those up. Control C, Control V, and there is my mean. So I'm going to go down here, and I'm going to keep up with this stuff. Mean is equal to 2.7. And I'm going to highlight that verde because it is what? Important. I might even put dang old grid around it. There we go. And you should feel good about yourself because you can find the mean of a what? A probability distribution. Because this, I'll do that in yellow. And let's go ahead and make that outside and inside. There we go. There's your probability distribution. So, Georgia plays who this week?
Kentucky.
Okay, that'll be a rout probably, even though Kentucky is trying. South Carolina plays Florida. I'll probably watch that one. Does Clemson play another high school this week? Oh, yeah, they play another high school. And LSU's got a bye week, or are they playing somebody? That'll be a rout.
Alabama's at.
Okay, there was a good, I guess, no,
Penn State, Michigan.
that's it. I want to watch the Penn State-Michigan game. I'll probably find another good one to watch.
There's another one at 3:30.
All right, so what's next? Didn't you say X what? Is she working on a calculator? I know. What are you pulling the calculator up for? I'm kidding. Oh,
doing-
you're moving ahead. Okay.
No, I'm doing the same question with different numbers.
Okay. Now, you said a while ago, what squared?
Shoot.
X squared. I was going to pull off your information. Okay, she's a failure too. All right. So, what do we need for our standard deviation? Look at the formula you just wrote down. X squared. So we need to have a x squared. I'm going to go over here. I'm going to skip a column, and I'm going to call it x squared. X. No yawning in class, please. And I'm going to do the first one for you. 0. Now, of course, it doesn't take a rocket scientist to do this. So I'll do the second one for you. 1 squared. 1. Okay. Now, what do we do with x squared now? Look in your formula.
Multiply it
By
P of X.
P of X. So x squared, I'm going to do this column, x squared times P of X. Now, you may want to use your calculator because you're going to have to, should be x squared times P of X, not plus, dork. There we go. Okay, I'll do the first one for you. First one's going to be 0. And I'll even do the second one for you. 0.1. So what's the next one going to be? Well, that's going to be 4 times dang old 0.3. And then I'm going to copy the rest down because I don't have a calculator and I'm not Rain Man. So there we go. Now look at your formula. I know it's a lot to have to look at the formula and read it. It's a lot. I know I'm asking a lot. It's easier just to ask the teacher, isn't it? But what does the formula say? We got to add what? Got to add these guys up. Summation. So take your handy dandy summation and add that up. And then we're supposed to subtract something squared. What are we supposed to subtract? I'm going to put x bar squared. So what is our mean? And then I'm going to put minus. I'm trying to do this in steps for y'all. X bar quantity squared. Somebody check me. Should be 7.29.
Yeah.
And that's equal to 9.5 minus 7.29. And somebody tell me what that is. It's not the mean. That's the what? The variance. 2.21. So how do I get the mean from the variance?
Standard deviation.
I'm sorry, yes.
Square root, right?
Yep. Raised to the 1/2 power. And that is how you find the mean and the standard deviation. Now I'm highlighting the standard deviation green, Verde, because it is very what? Important. Like always, the variance is really not that important. You only get the variance so you can get the what? Standard deviation. So now you can find the mean and the standard deviation of a probability distribution. So you need to highlight this problem in your notes, and you need to put a little check mark beside it and say Hubert's test, because this is what I'm going to test you on in 6.1. Question. Now, I don't think, I'm going to look right quick. I don't think, I'm doing here, And they just showed you how to do it right there. I don't like the way they do it, but to each their own. I'm gonna go through and look and see. Yep, we'll do the NC, okay. So, this is 6.2, I'm not gonna cover that. I'm gonna cover that tomorrow, because that's the second part of formulas. That's where you do NPX, and you use the calculator. You don't have to do anything but use the calculator. So, we're gonna shut her down, and all you need to work on 6.1. Is the test due? When's the test due? Okay, make sure you get the test done. And I will see y'all. Oh, I got to take the roll. Let me do that right quick. So don't leave yet. I'm trying to turn off the recording.